Hello, everybody. Hope you guys are doing well. So, continuing on our journey in Swift, so we were trying to deal with some async functions, right? Um, okay, so basically, we already studied what concurrency is, right, and how concurrency can be achieved, right? Okay, let me check if the stream is running as expected, and then there is one more. Just let me check if the stream is up and running, so then we can we can now. Yes, our stream is up and running, right? um, and let me see. Okay. Yeah, so um we are trying to understand. We already understood how async works. Now we have already covered some topics, right? Just give me 1 minute more. Okay. Just let me check one thing. My iPad needs to be synced, so what is it? Yeah, just give me 1 minute more. Uh, yeah, this should be my extended, right? But okay. Yeah, let's have this thing open here, and then um, let's. For some reason, the okay, it should work. Okay, let me disconnect, and then let me add, and then let this be. Yeah, and so Okay, so now everything is running. Uh no, here I need to, okay, let's no, no, let this be bank, and let's add another. Where is action display? And then yeah, so basically is it overlapping or something? Yep. So in previous sessions we have already um studied about how async and await is going to work. We studied about concurrency in the concurrency, using how concurrency works when we are trying to establish this using threads, right? Now let's see some code. Um, we'll try to understand some topics so that now async and await. Now by default in Swift everything is synchronous, we say. But what does that mean? Asynchronous is the one that executes. So suppose if you have a block of code, right? Now this is inside we are writing some code right now. If it's a synchronous function, then all the code inside will execute in a single line, right? That is what we meant by synchronous. Now, for example, if I write a function, so like if I have a function over here, so if you say this is func, and then you give this a function name, so this is function A, and then now anything and everything that is written here will be single threaded. But this has a number of advantages, but not least the synchronous functions are very easy to think about. It is very easy to work with synchronous, but then there's a problem, right? Now whenever one function calls the another, so for example, if I'm making one more function call inside this, so like if I have say a function c, so what is going to happen is, so inside so every function gets its own stack, right? Now see, internally this is handled as okay, now that means, so this is my function first, this is my function A, and then from here I'm making a call to functions, so I'm making a call here, and then I'm going to call my uh this is the call to function C. So I mean, so what happened here is, so when I call this function, another new stack frame has been created, right? This approach means that both A and C have a variable called counter, but they don't clash. Now whatever is going to happen is basically, now, and inside this stack frame I will contain all the local variables local to this frame, right? So yeah, I have all my local variables here, and even here I have my local variables, right? So these are all local to this stack, specific stack. Asynchronous function have an important answer, that is they are blocking. That means now one important point is blocking, right? So what if this means now if a function calls a function B and needs to know when what its return value is, then function A must wait. Okay, so now these are not returning anything, so there is no um issue, right? So what if I have a function, so suppose I'm going to have, say, this is my, so I'm saying val is equal to, no, this is my function B call, and then this is my function A, right? So now what is going to happen is, so now, okay, this is my function A, let's see, and this is my function B, right? So now this is going to come here. A new stack frame be created. So what if there is a code, say online number, on line number 36 in this function there is a code that is going to wait for some outside value to return to back, and the return statement is on line number 37. Now what if this return is going to take a time? Then what is going to happen is my code is being blocked. Now by code being blocked, what I'm meaning to say is this will come, this function. So if I have another return statement, right? So I'm saying after this line I have another statement. So say I have, say, print a. Now I'll be coming or reaching this line uh, only when I'm going to go ahead from here, right? So if I'm still, so until I do not have my value, I'm going to wake and I'm going to set. This is a very bad approach, right? Because not only we are blocking the function, so by blocking the function, what we're doing is basically we are wasting CPU time, right? Now probably thinking that waiting for a second is out, but then we would think that waiting for a second is going to be not. We assume because nowadays, so now latest we have the M4 chip, right? We have the M4 chip, right? Now we and then it has neuron as well. So now just waiting for a small function, you might think that that is not like it. I mean, since there is it is not, but then this is going to be um like since it's M4, so then and waiting for a second is nothing at all. But in computing terms, that's an ice age. Now we might say that we are just waiting for a computer for 1 second, right? But remember, the processors are defined or are made in such a way so that they can perform operations in milliseconds, right? So if you compare it to a second, then we are waiting a power of 10. Um, this sounds hence we can say um, hence we are because the way the new chips are designed is Stanford designed to perform 38 trillion things per second. So if you block a thread even for a second, that's like 38 trillion things that could have been done but didn't. One solution is to say if we got a blocked thread that's currently blocked, we shouldn't just launch a new thread. Now there are two ways of having this solution, right? So we are saying what he's trying to say is um, that okay. So now thread. Okay, what he's saying is if you have a thread that is blocked. So I have a because here my thread is blocked, right? So if the thread is blocked, thread is blocked. The thread is blocked. Then we shouldn't create new threads, right? We shouldn't create. That means, uh, but then what we are leading to is something called as threads explosion, where the system creates so many threads that it becomes a burden. So all those synchronous functions are easy to think about, but then they are not a very good approach. Hence, we need to move towards asynchronous functions, right? Now, what is an asynchronous function? Although asynchronous functions we can call other asynchronous. Now, what is going to happen is asynchronous is uh, mm, now see. So the solution to this is so the other way to do is basically to create a sync function, right? So use a sync function, right? Okay. Now, uh, the difference between synchronous and asynchronous is what we are going to learn, right? Now, okay. Now, all of Swift are by default everything is synchronous, right? This is a single thread. But then we can make them asynchronous by adding a keyword async. So we said to make a regular function. It's a regular function and we need to make it async, we add the keyword async. So regular function to async function. Uh, we add the keyword async. So we'll have to add the keyword async. Okay. Now, so this is synchronous functions that roll the virtual dice. Okay. Now let's go to uh, let's go to Swift Playground, and then let's see how things are going to work. I guess there is a online compiler. Okay, let's see new incognito. Okay, can we have a Swift Playground? Swift Playground. Let us see if there is any. I have Swift. Okay, we can do it this way. Let's open Xcode. So let's go to Xcode. Oh, why is it saying? Okay, I already had this thing installed, but let's go. Oh, it is. I guess it is this one. I don't know why it's taking me to install software. No, I should already have. Let's. I don't. Okay. Save online playground. Okay. Wait. Why does it tell me to? I already had. Do I have Xcode installed here? What happened to Xcode? Oh, there's an update that needs to be done. Let the update happen, and then let's get the new playground as well. Yeah, just give me. Just let the update be completed. It's taking some time, but then it should be done soon. Okay, so let's cover some theory and then. Yeah, so the way to make a function is synchronous is just to add the async keyword, right? So just by adding this keyword, the function is going to become async, right? Now, um, now okay, the only part now for async is a part of the functions type. Now let's study a little bit about async. So first is basically async is a okay. Uh, let's have this thing up. Yeah, so async is basically uh async is a part of the function type. He's saying so. Async what happened? Async is a part of the original synchronous functions returns, and so you need to mention the type there. Now by marking the code async, we have made it async. Okay, this is what I mean when I say, okay, close this app. Let's say continue. A third key difference. Okay, now second, notice that the word inside our function, the okay, so this is now how will we write a regular function versus a sync function? Let's see. We'll code it as well, but then let's see some little bit. So I'm going to generate a random number. This is my function. Then I'm going to say this is my synchronous. Okay, let's have two versions side by side so that I can compare. So this is my function. This is going to be my random number generation. So this will be random a. Then I'm going to do so in the and then okay, and then I'm going to say it is returning an integer as well. And then in the function body I have int dot random, and then this is my in, right? So in is basically, so in this to mention a range we use in, right? This is both mutually exclusive, so I'm going to say 5 to 6. And then on the other side I'm going to have a synchronous version of the same. So let's and then let's have another function. So let's say function random b. Then let's say now in the type itself we are going to make it async, right? Then this is async, and then we are going to say this is going to return. So even this is a random number return, but then the only thing is the code here will run in an asynchronous manner. So I'm going to say this is random. So this is dot random. This is int, so int library, and then I need to mention a range, right? So I'll be doing in 5 to 6. So inside this range parameter itself, we are going to get the value, right? Now, uh, so now, whenever we are dealing with cooperative threading, right? So cooperative threading means now use. So what we are doing is basically we are creating. Basically, we are achieving concurrency by creating multiple threads, right? Now that the way that thread pool is designed is to work as a cooperative thread pool, right? So this is designed to work as a this is okay. Uh, this is designed to work as a cooperative thread pool. Now, by cooperative, we mean that um, the so now when you have a thread pool, right? So you have um, a task queue, right? So you are going to put all your uh, threads inside this task queue, right? So by that, what it is going to happen is now when we say cooperative, these now the thread itself, no, this is basically the work that we need to put in here. So this is not my thread. This is the work that is going to come here in my task, and then what is going to happen is the the threads from this pool. So I will come and will work on these tasks mentioned, right? So these are threads. So this is T1. So these will come and automatically pick up some or the other tasks, and then it will be scheduled, right? Now by cooperating meaning what I say is if there is this So now I need to make a switch, right? Between, so switching needs to occur between these threads as well. Switching needs to happen between threads. Switching needs to happen between threads. Now, by switching, what I'm trying to say is, in cooperative threading, what happens is the thread itself will say uh, when to make the switch, right? So hence we need to do something called as yield, or we need to await, right? So that is basically why we are going to do that. Basically, hence we have that async and await paradigm, right? Okay. Now, did it complete installing? Uh, let's go here and check if. Okay, so yeah, my Xcron, but then it's still. I think so. This is my. If this is not, then I guess it's going to be this one. Apps is on. Just give it 2 3 more minutes, and then we'll see. So hence we need that await because of cooperative threading, right? Because inside the thread is itself we are going to make the switch. So okay. So async is basically we are going to mention that synchronously, and then the await is basically we need to suspend the execution, right? And so for that cooperative management that needs to happen, we need to do that cooperative suspension, right? So we that mean because we have a limited number of threads, if any thread is blocked we need to switch it, right? So we do this manually by mentioning await, right? We don't want our, so threads are valuable resources, right? We don't want them to, we don't want to waste our um thread, right? So okay, I guess it's now downloaded. Let's see if it, oh, it's working. Just give me 2 3 minutes more. It will be more oh, what happened to my this? It will be more clear when we start coding, right? You know what? Let's have this thing go here. This is much more easy. Let's, oh, it's still 43%. Let's give it 2 3 minutes more. It will be done by that time. Then for that cooperative pooling to happen, hence we need that await, right? because it is that cooperative pooling, uh, we need to make sure that resources are not wasted, right? I just give it 2-3 minutes more so that it's up and running. So that okay. So um, Xcode is up and running. Oh, it's still on 98. Let's go to app and then simulator is still take. So let's say this is test test file. Then go to next. Uh, should I put it in some folder? You know what? You can add it. Let's save it in my. Okay, let's create a new folder here maybe, so that we can have iOS present here. And then let's so in backend I have a new folder here. Uh, let's go. Wait. Okay, so our Xcode is let's run this and yeah, Xcode is let's go to playground. There should be wait, uh view. There should be a place to have playground running. Navigator, debug. Wait. Let's say our playground. So new, and then instead of having, let's go to playground here. Yeah. So this is basic. Oh, we are doing blank, right? So right now I've opened a new Swift playground. Okay. So this is how. Let's write. Yeah. So now let's write our async. Okay. So now let's create a async function here. So first, let's have a normal function return. Okay, so it's still taking. Okay, so let's go func, and then we say function a. Is it okay? Can we zoom this thing? No, it's going out, right? I don't know how to. There should be an option to zoom, but it's okay. This is function. Then okay, so you have a function a. Then this is my parenthesis, and then I'm going to return an integer, right? I'm going to say return 10, something like that. And then let's come here and let's call this so the print, and then let's call this function a. Oh yeah, now let's run this thing. Just give me a minute. For the first time it might take some time. Once it's running, then it should work. Okay. Okay, so the emulator has started now. It should work. The playground should work, I guess. You can open this as launching. Okay. It's still taking time. I don't know. Now, first, when an async